Hi guys, welcome back to the channel. This week we're going to start taking a look at some of the tools that we can use in the hobby to make our lives easier and to help, in this case, fault fix and diagnose issues without having to resort on social media for help. Now, if you don't already have a multimeter in your kit of bits and bobs, I think it's a vital asset for this hobby. And in this video, we're going to run through some of the different things that we can fault find, we can triage with a multimeter to try and establish where the problems are and get ourselves out of a pickle. We can also have a look and see how it might be used in planning for a show. If we've got a brand new set of pixels and we're not sure how much current they're going to draw, for example, to work out how many pixels we can hang off a single port at 30% power. We can do all this with a basic meter. Many of the multimeters available today look very similar. We've got 3 probe inputs, we've got a dial in the middle for selecting a myriad of different possible functions. We might have a backlight as this one does, and we might have a hold button so that we can retain a measurement so we can look at it slightly later. This is a very basic generic meter, typically about £20, $25 US off a well-known shopping site, and it's good enough to get you up and running in this hobby. But I would call this a basic or an entry-level model. Now, I've only got one other one here, and this is the one I tend to use on a daily basis, and this is what I would call a medium level model. This is by a well-known manufacturer in measurement and testing called Fluke, and this is a calibrated meter, so it will give you guaranteed answers, but the chances are they're going to be within 99% of this one as well. This one has less functionality around the rotary dial because it is auto ranging, whereas this one you have to give a good idea of the values you're expecting and then you can dial into the right level on here. This one also ranges for you. Apart from that, they pretty much do the same thing. They will measure voltage in both AC and DC. They will measure ohms, so the load across a cable or cables. They will measure amps, so we can measure the amount of power being drawn by a set of pixels, for example. They will measure continuity, so that we can tell if we've got a dead short, or indeed if our wiring is hooked up correctly and we've got a connection between two ends. This one would typically retail for about £200, 225 US. I actually bought this off Facebook Marketplace because I couldn't justify that amount of money. And it's worth looking for. It's a good solid device and it's going to last me a good time. Now typically you'll get a little set of probes with your meter like these little ones here. A red one and a black one that you can use to poke into different areas. The Fluke again comes with a set of probes, but it also came with, in my case, as an optional accessory, you can get a set of different wires and different probes, clips and things to connect onto different things. So you can hook them on with a set of crocodile clips, for example, or these ones, let's have a look, these ones here are a set of little hooks which you can just hook onto something and then leave them there. For a beginner who's not doing this all the time, the £25 version is absolutely fine. Now the first function I'm going to demonstrate is measuring DC power. And quite often we need to know if we've got power coming out of our controller so that we can establish, when we're trying to fault find on a string of pixels that won't light up, where the fault lies. So number one is the controller producing power and feeding the pixels? So to do that, we can hook up our meter. I'm going to plug the black probe into the common center terminal on my meter here. Now the left-hand red input on the meter is labelled A and is usually used to measure amperage. The right-hand side here is labelled volts, ohms, audible, and that's for use in making sure that we've got continuity or whether we're measuring volts or resistance on a line. We're going to be measuring volts, so I am plugging into that side. There we go. Next, we need to turn the meter on and tell it what we're going to be doing. So the first two options going around the dial here, we have volts with a sine wave, and that is our AC volts. So that can be used for measuring the power going into a power supply on the mains, be it 240 volts over here or 110 in the US. That's where we measure with that one. And if you're doing that, make sure, of course, that you don't touch it with your fingers because it goes sparky bang and it hurts. And I have done it, as most of us will have done at one stage or another. Voltage with a straight line is voltage DC. So that's going to be our output voltage at 12 volts, at 5 volts, 24, 48, whatever. If we're running at particularly low voltage, we've got a millivolt option here as well. We're not going to be using that one today. I've got ohms so that we can measure the resistance of a circuit if that's something we need to do. Not that common in our hobby. I've got an audio signal here. Now this is for measuring continuity, and the reason it's labelled as an audible signal is that it will beep at us if we get a dead short or continuity between our 2 points. The next one is for measuring diodes. We've then down the bottom got A with a wavy symbol, and that is for measuring amps on mains voltage on AC. And the last entry I've got here is A with a flat line, and that is for measuring amps DC. So that's what we can use for measuring the amount of power being drawn by a bunch of pixels coming out of a port. And that would be very useful when we come to working out how many pixels we can hang off a port. Because if we know that this bundle of 50 pixels consumes X number of amps, then we can multiply it out. So let's start with volts then. We'll start at the beginning with volts and AC. There we go, and that can be red, that's good. So we're on volts AC, so I've got V with the wavy line. And I'm just going to hook this up to the positive power in, so the mains inputs, live and neutral on this controller. So hold your fingers back up the probes because we don't want to hurt ourselves. So I'm going to touch that onto the neutral, and this one is going on to live. And we can see on the screen that we're rocking at approximately 239 volts here today. So that's good. Power supply is getting what we need. So that's part one of our test. Has the power supply got voltage going in? Yes, it has. And that kind of makes sense because we can see the green power on LED in the corner, but it doesn't hurt to test. Next one I'm going to test is to make sure that this power supply is producing the 12 volts that we're expecting. So I can rotate us to volts with a straight line, which indicates DC. Again, red onto red this time, and black onto black. And we're running very slightly over here at the moment, but we're on no load. So that's 12.07 volts is coming out of our power supply. We can then test power going into our controller. So I can drop that down into the screw terminals once again. As expected, we're still 12.07 volts here onto these two terminals. And we can then test the outputs on some of these strings. Now let me see if I can get, these can be a little bit awkward. I don't know whether this is going to reach. No. The little contacts on the end of these probes are fairly fat, and so they're not going into the Phoenix connectors. Fortunately, on these ones, these little safety caps are removable, so I can attack again with a slightly longer. There we go, I've got it. I'm on back to front, so it's given me minus 12.07 volts because I've got my probes back to front. But I got on there in the end. So that's proving that we have power coming out of our Phoenix connectors. Now if I didn't have the actual Phoenix connector in the socket, it would be a bit easier. I can go straight on to the terminals here. There we go, 1 and 2. And there we are, I'm still back to front. 12.07 volts. Now I'm back to front, so if I swap them over and I actually connect onto ground and positive properly, there we go. We've got 12.07. So we have power coming out of this side of the baldric, so we know that is good. And if I do this side as well, let's give it a stab. There we are. And we've got 12.07 coming out of that side. So we know we've got no issues with fusing on here now. Our fuses are all good. Particularly, well, certainly on this socket and this one where I've just been testing. How else could we prove that we've not blown a fuse apart from sticking a voltage meter onto the Phoenix connector? We could by pulling the fuse and testing the continuity. So let's give this a wiggle. There she comes. Yeah. So I have my fuse, and looking at it, it looks to be intact. I can't see any burn marks, and I can see the clear fuse wire hoop inside the fuse. But just to confirm, we can do a continuity test. If I rotate the dial here to the audio symbol, the audible, that will give us continuity, and it will test whether the two sides of the fuse are joined together internally. So I'm going to hold these in one hand and just touch the fuse on, and there we are. We could see a 0 ohms displayed on here, and it was buzzing at us to tell us that it's a good connection. So this fuse is fine. If I did it without, on a dead fuse, we wouldn't get the beep and we wouldn't get 0. It would just say OL for overload, as it currently does when the two probes are not connected. We can confirm this by simply touching the two probes together. There we go, no resistance between the two, and that's exactly what we saw with the fuse. So that's given us the basics of testing a fuse, testing our power in and our power out of our power supply, and the power in and out of our controller. But how would we test the cabling to make sure that that is working? Well, I've got a pixel pigtail here, and if I get, this one is a female which carries the load, and I've got a male pigtail here as well, so we can just check that the pigtails are working. If I join these together, come on, thank you, there we go. If I join these together, we should now have 12 volts on our black and red cables. Now your pigtails may have different colours. I'm using the ones from Build a Light Show here in the UK, and they are conveniently labelled red for positive power, black for negative, and yellow for data. So let's stick red onto red. Oh, rotate us back to volts DC. There we go, I've got volts DC and I've still got 12.07 volts. So I know now that my pigtail is good. So I've got power here, and that is good. next thing we can test is that we've got power through our string of pixels. So again, I've got start and end. Now we don't need any data on the string at this point. If I simply hook up the pixel string to the pigtail, there we go. One, that's in, and then I'm going to hook up my male pigtail to the end of the string, and we can check the power down the string is good because I can tap the red and black wires just the same. As long as red and black has continuity all the way through and we get a voltage out at the end, then we know that there are no major issues with this string of pixels. There might still be issues with the pixel themselves, that they're not passing data, but there's no voltage issues. So if I hook that up again, I would expect to see slightly less than 12.07 this time, because there is a little bit of power going to be used by these pixels themselves, even though they're not doing anything. And there we go, we've got 12.01, 12.00 volts at the end of my pixel string. So we know that the positive and negative wires on this string is good because they're passing voltage all the way through. Next thing we can test is how many amps these pixels are going to be drawing. Now, one of the easiest ways to do that is simply to unplug the fuse from the relevant port on our controller, and then we can hook the meter to the two terminals that the fuse would normally connect to. And instead of passing power through the fuse, we're going to pass power through the meter, and it will then be able to measure the number of amps being drawn. So with no data on the circuit at all, if I unplug the first fuse here, there we are, I'm just going to check that we've got no power now. If I plug my pigtail back in, I should have left that plugged in, shouldn't I? There we are. If I hook up, now we've taken the fuse out from port number 1. If I hook up my meter now to, there we are, we have 0.00 volts. So we've got no power to these pixels because I've pulled the fuse out. What we can do now is we can unplug, I'm going to turn the meter off, I'm going to unplug the red plug from volts and plug it into amps, and then I'm going to rotate my dial to amps AC, amps DC, which is A with a straight line next to it. If I now connect my meter to the two sockets that the fuse would normally plug into, the power will pass through the meter on the way to the pixels, and therefore the meter can measure the amperage. And this is with no load, with the pixels turned off. So there's the first one. And then let's drop the second one on. There we go. And I am the wrong way around again, so I'm just going to reverse these because I had a negative value. Oh, drop that one. Let's give that a go. There we are. Now this is where the crocodile clips come in really handy on this meter, because you can just hook them up and leave them there. There we are. So we're drawing 0.096 amps on our meter. So 0.096, so 0.1 amps for these. I think we've got 50 here in this bundle, and that's with no load or no data to the circuit. So we've got an idea of how much they're going to draw with nothing. Having measured how much power in amps our string is pulling with no data on it, we can do some testing using our controller, and we can see how much power our string is going to produce at, say, 30%. If I go into the setup here and go for test mode, full white at 30%, there we are on all ports, we can see that our pixels are illuminated, and we can see that we are drawing 0.49 amps with these particular pixels. So 0.498, 0.5 amps, shall we say, for 50 pixels. That's about 0.1 amps per pixel. If we take the 0.5 and divide it by 50, we're about 0.1 amps per pixel. Multiply that by the 7.5 amps that this particular board is capable of outputting, and we have 7.5 amp fuses on here, then you could, in theory, run about 750 pixels at 30% brightness off the one port. Now, conveniently, Baldric maxes out at 750 pixels per port, so that's really good. That all makes perfect sense. So we can run 750 of these at 30%, and we know we're going to be good. We're going to be inside the level of the fuse and within the recommended values of Baldric. So that's all good. How does that change if we change to a rainbow? We can see now as the pixels are running through their rainbow test, our amperage is varying. It's typically about 0.3 amps thereabouts for a rainbow. So that gives us a good idea that our test at full white, 30%, is going to be the worst case scenario. And as long as we cater for the worst case scenario, then we're all good. Now, one other test that I like to do is to see how many volts are going to be available at the end of this string of 50. Just because we can feed it 50, a full 7.5 amps, how many amps are going to be available at the end? Now, I've just lost my fuse. There it is. Let's put the fuse back in. There we go. So they are once again illuminated. And if we look at the volts now, I'm going to put the probe back into volts, rotate us back to volts DC, and let's see how many volts we've got at the end. 11.74. So we've dropped about 1/4 of a volt on our 50 pixels. So I think that's going to show us that although theoretically we could stick 750 pixels on a port, the pixels themselves aren't capable of transmitting or transferring that much power all the way through. Now, this depends on your vendor, the weight of the cable being used on the pixels, the quality of the soldering onto each PCB, the quality of the tracks on each PCB for the amount of current that's going through. Losing 0.25 of a volt at 12 volts across 50 pixels might not seem much, but if we stuck 200 on there, then we would be down to 11 volts by the end, and at that point you're going to start to see variations in color. So a really good thing to be able to do is to hook up a meter onto the end of your string and see what your voltage is doing at the end. And then you can work out whether you need to power balance or do something else. That has given you a little bit of an insight into the use of a multimeter. So we were able to measure the voltage coming into our power supply to make sure that that was good. We were able to measure the voltage coming out of our power supply to make sure that that was equally good. Voltage going into the controller, voltage coming out. So we know that the power supply side was good. We measured the power at the end of the pigtail. So we know we got power to the start of the pixels, and then we measured it at the end even. So we knew the power was good all the way through. We then looked at amps, so the number of amps that we're drawing through the pixels. At no load, they were drawing about 0.01 amps, and that's what I would expect because the ICs in the pixels are up and running. They're processing data, albeit there isn't anything to process, and the LED isn't lit. But the WS2811s or whatever in there are doing their thing. We then looked at the amps being drawn with them on 30% white, and we were able to demonstrate that we were pulling about half an amp on 30% white. And so we could calculate that out and say, in theory, we could run 750 pixels off a 7.5 amp port. But then we demonstrated that the voltage drop of 1/4 volt across 50 pixels means that the cabling on here isn't up to pulling 7.5 amps at that rate. So we would have to look at either power injection or power balancing if we wanted to go to more than about 200 pixels. Pulling 1/4 amp, pulling about half an amp and dropping about 1/4 volt along 50 pixels. If we ran 200, we'd be at that rate, we'd be dropped to about 11 volts at the end of 200 pixels, and then you're going to see color variations at the end. If you power balance, then you'd be able to up that and so on. So I think that gives you an idea into the use of a multimeter. You can't easily break one. If you're doing amps, plug it into A. If you're doing volts or continuity, plug it into the other side. Black one always goes in the middle. That's about it. So if you haven't got a multimeter yet, get one. You'll find it really useful for double checking everything and make sure everything is good to go before you break something. And if in doubt, ask. There we are. That's this week's technical items. So a multimeter for the noobs this week is definitely a recommended item. I'm running a more expensive one here, but sort of £25, £25 one off Amazon, $20, $25, $30, something like that. Will do just fine, and we'll do 95% of what this one does. You might not have the calibrated answers, but you don't really need them. As long as you know that it's working, then happy days. Have fun, have a good week, take care, see you on the next one.